Okay, so let's go ahead and take a look at the solutions of these problems. So in order to do this, the first thing I'm going to do is rewrite my equation so that it's easier. Take the derivative, and this gives me g of x. Let me scoot it all over. G of x is equal to x to the 4 over 3 plus 4x to the 1 over 3. So let's take this derivative. I get g prime of x is equal to 4 over 3 x to the 1/3 plus 4 over 3 x to the negative 2/3. Right? So what I'm going to do is I'm going to pull out a negative 2/3, an x to the negative 2/3, and a 4/3. So I get 4 over 3 x to the negative 2/3. And if I do that, I'm going to see if I pull that out, I get 1 over 3 minus negative 2 over 3. This becomes a positive, which gives me an x, plus 1, since that's exactly what I pulled out. And then if I rewrite this, I get 4 times x plus 1 divided by 3 x to the 2 over 3. Okay? So let's find our critical points. So critical points are when 4x plus 1 is equal to 0, and when 3x to the 2 over 3 is equal to 0. So let's go ahead and solve these. If I divide by 4, I get x plus 1 is equal to 0, and I get x is equal to negative 1. Right here, if I divide by 3, x over 2/3 is equal to 0, and this is only true if x is equal to 0. So I have two critical points. So let's go ahead and draw our number line. Let's see, right here. And oops. Let's extend this number line right here. And let's do exactly what we did in our previous example. Okay. Let me just make sure we have this up here. Okay. So I have two critical points. One is negative 1, the other one is 0. And what I'd like to do is to find out what these derivatives are. So since this one was my numerator, I know the derivative of this. Let's go ahead and copy. I would like to copy this real quickly. What we notice is this is my numerator, so the derivative of this is equal to 0. This was my denominator, so the derivative of this was undefined. So let's go ahead and pick some test points. So let's pick a negative 2, negative 1/2, and a positive 1. And let's go ahead and take a look at these. Right? So I do have a fraction. So let's take a look at the signs of these fractions. The top part is 4 times x plus 1. So let's write that out here to the side. 4 times x plus 1 divided by 3x to the positive 2/3. So let's take a look at what happens. Well, in this case, if I plug in a negative 2 into here, what I'm going to get is a negative number on top. And if I plug in negative 2 into here, this is the same as the cube root of x squared. Well, since I'm squaring that negative number, becomes positive. So this bottom is a positive number right here. And in any case, since I'm squaring all of them, these all have positive denominators. So we're just taking the top now. if I were to plug in a negative 1/2 here, that would give me a positive number in the top. And if I were to plug in a positive 1 here, I'm also going to get a positive number. So if I were to take a look at this, in this section, what you'll see is I have a negative over a positive, which will always give me a negative value. Here I have a positive over a positive, which gives me positive values. And up here I get positives and positives, which gives me positive values. So let's take a look at what this is telling us. Negative numbers are telling me I'm decreasing. Positive numbers are telling me I'm increasing. And if I were to sketch this out, let me scroll down just a little bit, I see that I would be decreasing here, increasing here, and if you notice, I continue to increase right here. So if that's the case, what kind of point do I have down here? Good, this is my minimum value when x is equal to -1. And if you notice, nothing is really happening up here. So let's do our intervals of increasing and decreasing. So according to this, I'm going to make sure I take a look at my x values. I'm decreasing from -infinity up until this -1. And then I'm increasing from -1 up until 0. And I can't do anything here at 0 because it's undefined. So I have to continue and say in union with 0 to infinity. Now I have to find where this minimum is. And if you notice, I don't have a maximum at this value per se because there is no maximum value. Just this just keeps going on and on and on this side. So I can't really pick a maximum value. But I can find this minimum value when I set this equal to x equal to -1. So my original equation says g of x is equal to the cube root of x to the 4th plus 4 cube root of x. If I plug in 1, -1, I get the cube root of x, -1 to the 4th plus 4 cube root of -1. This is to the 4th power, so I know that will give me 1. This is the negative cube root, so that gives me plus 4 times -1, and that will give me 1 minus 4, which is equal to -3. So my minimum is at -1, comma, -3. Good. So let's go ahead and do the next problem right here. I'm going to use a chain rule to take this derivative. So I get 3 times 2x minus 3 squared times 2. That gives me 6 times 2x minus 3 squared. And if you notice, I only have one factor here, which is this 2x minus 3. So let's set that equal, minus 3 equals 0, so 2x is equal to 3, so x is equal to 3 over 2. So what we're going to do is draw our number line. So I'm going to do this one right here. That's not what I wanted. So here's my number line. And I'm going to pick numbers that fit this. So my critical point is at 3 over 2. So a number bigger than that is going to be 2, and a number smaller than that is going to be 1. So let's go ahead and see what happens to this. I know from my derivative, this was equal to 0 because of finding my critical point. If I plug in a 1, you notice this whole thing is squared. So no matter what, this is going to be positive. Same thing here. If I square this, I'm also going to be positive. So if I'm taking a look at these intervals, what I do notice is this is increasing and this is increasing. So my graph is just going to go up this way. So I can't declare a maximum or minimum. All we could actually say is that this is increasing. And because 0 is here, it counts from negative infinity to infinity. Okay, so that's it for this section.